Hello and welcome to video 11 for Math 123. This is the fourth and the final video for our probability and statistics information. So for the statistics, we've been talking about the different steps: collect data, analyze data. Third, so once we've done all that work, we want to present it to people. We're putting all this work in for a reason. So now that we have it done, we want to present the data. And there's a few ways we can do this. If it's categorical data, and categorical, still having my spelling struggles here, categorical. So this was what? This is male, female, poor, fair, average, good, very good. So we have different ways that we can present this. We can do it in tables. We can do it in bar graphs. We can do it in pie charts. With pie charts, we have to be careful because it must equal 100%. So let's say we were doing the fair, poor, or poor, fair, average, good, very good. You know, at a certain restaurant, if you guys go on Yelp, it has all the star ratings. So maybe instead of that, let's do the stars: 1, 2, 3, 4, 5. So you pull up a restaurant, and it has what, like 4.5 stars colored in. So that's presenting you the data, all the people that have been rating it: 5-star, 4-star, 3-star. It's calculating all that and giving you a category that, okay, this is between good and very good restaurant. We also have the quantitative data. So we have all these numbers. What's our best way to present it? So we have what's called a histogram. And it's similar to a bar graph, but it's continuous. So with a bar graph, you might have had just, again, if we do like the male or female. So male, 20. Female, 25. If like how many students are in a class. 20 of them are male, 25 are female. So it's just going to be bars. They're not connected to each other versus a histogram. So an example of this could be ages. So maybe ages of, I don't know, people live in an amusement park. We'll use that again. So if we had that, it'd be what? It'd be, okay, 0 to 10. How many people of that age? 10 to 20. Oops, 20. How many people are at that age? And maybe this is, you know, how many people? 5, 10, 15, 20, etc. How many between 20 and 30? How many between 30 and 40? So it's continuous. You can look at it and there's no gaps between it. So that's the difference between the bar graph and a histogram. The second type is a line graph. And it's similar to what we just had there. Whoops, line graph. So instead of drawing all the bars, we might have 0, 10, 20, 30, 40. So however many points there were, and what did my picture look like? So it might look something like this. So it's the different points, and it's a line that's connecting them rather than the bars that we had drawn in, etc., for our histogram. And the other type we can use are dot plots. And so again, if we're going along the same deal here, 0, 10, 20, 30, 40. So maybe between 0 and 10, there's this many people. 10 to 20, certain number of dots. So it's how many dots represent how many people fall within that area. So that's just ways we can present it. We will do some of these in class. Not really a lot for examples here. Again, just to reiterate, for your guys' intent and purposes, what you really need to know from the statistics information is mean, median, and mode. You will have a little bit of chart reading you have to do, especially on the praxis, but again, your focus should be on those three types of information. And then 4 is our interpreting. So the biggest thing with interpreting and how it relates to statistics is this idea of correlation. So let's talk about heights again. There's a correlation between a person's height and a person's age. So you don't have a 10-year-old that's 6 foot and then a 20-year-old, then that same person at 20 is now 5'5". There's an upward slope for a person's height. So that's correlation. If we plotted all those points on a graph, we would essentially start to see a line that, okay, and like a lot of times you like see people, parents talking about their kids, oh, they're in the 75 percentile for their size. That's what's happened over time. They start to say, okay, an infant this old should be this long, should weigh this much, and they kind of use that as their guide. If it's perfectly correlated, it'll be a straight line. In real life, nothing is ever a straight line. What we would have is what? We would have a bunch of different points. Maybe this is height and age again. So it's close, but we couldn't connect all these dots with a straight line. But we can sort of draw a line through the middle, and we can see that it's pretty well correlated if again, this is age and height. So if we plot ages versus height, we're going to see this upward trend. And the closer they are to that line, so again, getting a perfect correlation in real life, we're not going to see it. But the closer they get to that line, the better correlated they are. So if our dots were like this, with the blue, it still might be that black line going through the middle. However, there's not a very good correlation because there's a lot of distance between that line and our data points. So again, I keep going back to when you're interpreting, make sure that you're understanding what's being given to you. They might say, oh, this line is a good interpretation of the data, but is it? Well, it goes through the middle, but you can't really say that, oh, okay, I know that if the person's 20-year-old, they're going to be this height, because there's so much what we call variance in the data points. So be careful with that. And then the last little bit here, so a shorty video again for you guys. Last video was the long one. Again, that's the meat of the matter. But correlation varies from -1 to +1. -1 is perfectly correlated with negative slope. So in this case, let's see, maybe if like exercise. So maybe we start plotting the point like, okay, how much does a person weigh? And now they start doing some cardio on a treadmill. And then what are their weights? Well, ideally, it's going to be coming down, right? And we can start to see that, all right, if somebody spends 10 minutes on a treadmill, they're losing this much weight. If they spend 30 minutes on a treadmill, this much weight. 45 minutes on a treadmill, that much weight. And again, because we're talking about weight coming off, it's coming down, so it'd be a negative slope, and if it's perfectly correlated, it would be -1. Correlation of 0 means not correlated at all. So let's say spending time sun tanning by the pool and my weight loss has nothing to do with each other. Whether I spend 10 minutes out in the sun, 30 minutes or 45 minutes, it has no effect on weight loss. So they're not correlated at all. That would have a correlation of 0. And then +1 is perfectly correlated with positive slope. So if we want to talk about this weight loss, or now let's do weight gain theme. If I eat an extra 500 calories a day, I'm going to put on this much weight. If I eat 700 calories extra per day, I would put on this much weight. If I eat 1,000 extra calories, I would put on a whole lot more weight. And that's going to be upward slope. I should probably do it this way, right? Upward slope. If it's an exact match and perfectly correlated, it would be +1. So +1 perfectly correlated going up, -1 perfectly correlated going down. So that's it. That wraps up our 4th video on probability and statistics. Come on back. We're going to look at our next batch of material. That's geometry. We'll have a few videos on that. And then the last video is just going to be some test taking tips for you guys. So as you start getting into actually taking your exams or taking the practice, if you go on to that, just some tips and some hints how to give yourself the best chance there. So come on back and we'll get into that.